So here's the uniform beam, and because it's a uniform beam, the center of mass is here, right in the center of the beam, so it's acting downwards 15 newtons. We have got a weight sitting on the beam here, 13 newtons. Got two unknowns. We've got a reaction force on this side at the support, and then we've also got a tension in the string on this side. So this is holding the beam in equilibrium. So two unknowns. We don't know the reaction force and we don't know the tension. So we need to get one of the unknowns, get rid of one of the unknowns. So wherever you take a moment about, so say if I take a moment about A, like that, then I can ignore that tension force because the moment due to that tension is zero. So take the moment and it'll cancel out the unknown. So from there, with respect to that pivot, the moment anticlockwise due to this force plus the moment anticlockwise due to this force must equal the moment clockwise due to this force. So these must be balanced if it's not moving, if it's not rotating around. So you can write an equation. So with the anticlockwise, you could write anticlockwise. You have got 15 newtons times 0.6. So just turning it into meters. Plus, and then you'd have 13 newtons times, well, the distance away from the pivot here, it's not 60, it's, well, the distance for the whole beam is 120 centimeters. So minus the 80 gives you this. So this distance here would be 40 centimeters, like that. So this would be times by 0.4. So that's the anti-clockwise moments due to these two forces. And then the clockwise moment is due to r at a distance of 120. So it would be r times, put it into meters, 1.2 meters. So those are your moments. So anti-clockwise moment due to the two forces, 15 and 13, and clockwise due to the reaction force at a distance of 1.2 meters. So it's balanced, these must be equal. So you can write R times 1.2 equals to 15 times 0.6 plus 13 times 0.4, and then just divide by 1.2. So the reaction force is 15 times 0.6 plus 13 times 0.4, and then just divide by the 1.2. And if you put that in the calculator, just care for the brackets, you will get 12 newtons. So quite a typical question. So you've got two unknowns, the tension and the reaction force. So if you want to get rid of one of the unknowns, take the pivot at that point.